Thank you for participating in the Indiana University Department of Earth and Atmospheric Sciences Science Fest activities. We had hoped to join you in person for our annual trash can volcano eruption, but a digital version will have to do this year. Please enjoy this video explaining the basics of volcanoes and how our trash can model volcano represents a real-life volcano. What is a volcano? A volcano is a vent through which molten material, magma, finds its way from Earth's interior to the surface. Volcanoes come in an extraordinary range of shapes, sizes, and eruption styles, depending on the physical and chemical properties of the magma. Volcanic eruptions range from gentle effusions of liquid lava to violent, explosive eruptions dominated by fragmental volcanic ash. Violent volcanic eruptions are powered by gases that are dissolved in the magma, primarily water vapor, carbon dioxide, and sulfur dioxide. What we're doing today is creating a simple model of a volcanic eruption, one that illustrates the features of an explosive volcanic eruption. Our model is a pretty primitive one. First, we have a plastic trash can which represents the rocky edifice of the volcano. We fill the trash can with water, which represents the magma chamber inside the volcano. We then cover the water with ping pong balls, which represents the overlying rock. We fill a plastic bottle with liquid nitrogen, which represents the explosive source of the eruption. The plastic bottle is then taped together with bricks to keep it at the base of the magma chamber. Before the video began, our volunteer volcanologists, Clark and Danielle, prepared the volcano by filling the trash can with water and covering it with ping pong balls. You can see Clark carefully filling the soda bottle with liquid nitrogen. Once the bottle is filled, you can see Danielle quickly capping the bottle and dropping it carefully to the bottom of the trash can. Let's watch that again in slow motion. As the liquid nitrogen warms, it changes state from liquid to gas, rapidly increasing in volume. This is equivalent to the exsolution or bubbling of volcanic gas as the magma approaches Earth's surface. The increased volume of gas puts increased pressure on the walls of the plastic bottle, pushing against its sides and the overlying magma. Eventually, the pressure exceeds the strength of the bottle, and it catastrophically explodes, pushing the overlying rock and magma out of the vent of the volcano. Much of the material is erupted vertically, but sometimes the volcanic edifice is fractured and results in a lateral flank eruption. As the material enters the atmosphere, it is broken into small fragments known as ash and gradually rains down on the surrounding area. If there is wind, the ash may be blown primarily to one side of the volcano. In a real volcanic eruption, the sudden release of the overlying pressure, equivalent to removing the cork from a champagne bottle, would induce additional release of gas from the magma. This release of gas would result in a positive feedback system, resulting in more pressure, pushing more magma to be explosively released, ascending into the atmosphere. In a real eruption, the initial eruption might trigger an extended period, from days to weeks to even years of continued volcanic activity. The impacts of explosive volcanic eruptions can be severe, with casualties numbering in the thousands and impacts extending for hundreds of miles. In modern eruptions, volcanologists are often able to identify the signs of rising magma, release of gas, or fracturing of overlying rock that might indicate an impending eruption. These signs can, in turn, be used to warn authorities and evacuate residents prior to an explosive eruption, and can save thousands of lives. Thank you for watching the Indiana University Department of Earth and Atmospheric Sciences Trash Can Volcano video. Please join us at next year's Science Fest to, hopefully, see the eruption in person.